A lovely demonstration here from Better Equipped of Lenz's Law. So I've got two cylinders here which look like they're exactly the same, but one is magnetic, one isn't. So this one isn't magnetic. There we go, flies off. Okay. Now this next one is magnetic. Huge difference. So by Lenz's Law. Look at that. A lovely slow descent. A little demonstration you can do with a strong magnet and aluminium. Okay, so if I put the magnet on top piece of card, now I should just be able to pull the card and pull the magnet away, but much harder, right? Eddy currents, Lenz's Law. Yet another little demonstration of Lenz's Law. Okay, here we've got a kind of reverse of a typical Lenz's Law demonstration. In the past, I've done, and I've seen it done quite a lot of times, you have an aluminium block and then a magnet swinging, but this is the opposite. We've got a really powerful neodymium N52 grade magnet here. Be careful how you handle this magnet, where you put it and keep it. And then we've got an aluminium ball. Okay, so if I just remove the magnet for now, see it already set that swing in. If you swing, pendulum goes on for quite a considerable time. Okay, now you can see it swinging quite freely there. Okay, now if I do the same thing, let me just unravel it a little bit, with the magnet in close proximity, then we get a bit, quite a significant damping. Okay, look at that, it only swung a couple of times there. Okay, try it again. Look, really strong damping effect. Also, and it's not touching, it is, maybe I'll move the phone to show you in a second that it isn't touching the ball. Okay, but you can see as it moves, if you move the magnet around, it moves the ball around, again by Lenz's Law. So quite nice to see a sort of reverse of a typical case there of Lenz's Law. Let me just take the phone and show that it isn't touching. Okay, there we go. Nice little demonstration of Lenz's Law yet again. Here we've got a really strong neodymium magnet, and then next to it here we've got some aluminium plates. Okay, so a bit of Lenz's Law in action here. So if we bring them quite close, we can make the magnet move, look, without touching it. And what if we try and move one way, one the other? It turns. Cool, isn't it? Okay, got a demo here today using these little sort of toy magnets. These ones make a noise if you sort of throw them together like that. Okay, but they can also be used to demonstrate Lenz's Law. So yet another Lenz's Law demonstration. So if I just take one of them, if you spin it, it'll spin on, this is a Corian surface quite nicely for ages, like that. But what if we spin it on a non-magnetic metal surface? So here I've repurposed some density blocks. So these are just aluminium blocks from the density experiment. And look, you try and turn them and that's it. It hardly spins at all. And you might think it's maybe the rough surface of the aluminium, but if I take a tray, so if I take a tray here, it's quite a thin tray, okay, so that spins quite well on the tray because there's not much metal there beneath it, okay. But if I take that and now put it on top of the aluminium, and again the same thing will happen as before. You see, it hardly spins. So another demonstration of Lenz's Law in action there, this time using repurposed equipment, really, okay. These only cost £1 or £2, novelty shop. And then these are just repurposed density blocks. Copper, aluminium, anything like that will do. And you can see this really is quite an obvious effect compared to what it was before. Okay, with that I'll spin happily, take the other one, and then you can see quite starkly there now that nothing's happening. There you go, Lenz's law yet again. Neodymium magnet, specific heat capacity blocks. Lenz's law. Okay, I've had a few people ask me about copper and what it'll be like there. So we've got copper specific heat capacity blocks there now, okay. Lenses lower again. Okay, so today we're going to float some Japanese yen using surface tension. Hopefully I'll try and float 3 of them. There you go, there's 1. So it's made of aluminium, but aluminium is denser than water, but the surface tension gives it an added component which helps it float. So contrary to what most people would probably imagine would happen, got to be very careful. This is just a paper clip. Okay, so first of all, see if we can do, this is a fun fly stick. Okay, so a handheld Van de Graaff generator. So see what happens now with this. So charge it up and you can see that it's moving, deflecting the coins, repelling, right? Yeah, there. So there we go, that's the handheld fun fly stick. And so that's electrostatics, and let's have a little look now at magnetism. So these are 3 neodymium magnets, which are very strong. Aluminium is not magnetic, but by Lenz's law, we should be able to get some movement going, okay? So there you go, I'm not touching it, if you could see. You can see by Lenz's law, we're getting movement, so we can manipulate where these are going. There we go, so that in the middle, let's try and get this one back in the middle. And this one as well. There we go. Bit of Lenz's law as well, so electricity, electrostatics and magnetism. There we go. Hi there, nice little Lenz's law demo to show you here. So we've got 3 neodymium magnets here taped together on a piece of string connected to a burette stand, wooden. And here we've just got a pie case, okay, they're not touching, okay. And if we spin this round, by Lenz's law, look, you get it spinning one way, spin it the other way, the magnet. By Lenz's law, you get it going that way. Isn't that fun? Not touching at all, okay. Just Lenz's law in action. Simple demonstration with simple, easy to get hold of kit. Hi there. Here I've got a circular turntable and then I've just blue tacked this aluminium plate onto the top of it. And as you can see, that's spinning nicely, and that'll probably spin for a minute or 2 maybe, okay? Especially if I give it a really good spin, okay? So let's just get this going again. Here we go. That's going really fast. What about a really strong neodymium magnet? Bit of eddy current braking. Look, stopped it pretty quickly, okay? Let's try that again. Happily going along, very low friction. Apply the eddy current brake. There we go. Really strong magnet, that one. See, it didn't have much of an effect in the middle, did it? But on the side it did. Let's try that again. Straight on the side this time. Eddy current brake. Okay, here we've got a nice little eddy current demonstration unit from Philip Harris. So power supply here, supplying a motor, and hopefully we'll get this going now. So you can see then this aluminium disc rotating, fairly high speed, okay? And then if we bring the magnet close, you can see a bit of eddy current breaking there, okay? You can rotate the wheel by hand if you want, just using the motor here, okay? Really effective demonstration of eddy currents, Lenz's law yet again. Nice little unit. Hi there, this is a nice bit of kit for looking at Lenz's law and eddy current. So you've got two rings here suspended by a horizontal bar. This ring's got a slit through it, the other one is solid, okay? So if I leave it like that, if I take a strong neodymium magnet, and if I insert it without touching inside the solid ring, you see it pushes it, okay? You can even pull it a little bit as well, or push it from the other side. Now what about the ring with a hole in it? There's a slight, very slight effect, but nothing much. Nothing like as strong as this one. You can push this all the way around, look, without touching it. Lenz's law. Hi there. Here we've got a little ramp and we've got a piece of aluminium, and then on the underside of this ruler that's acting as the ramp we've got a strong neodymium magnet, okay? So look what happens when we let this go down the ramp. If you saw it slow down a little bit there in the middle due to Lenz's law. Detect that slowing. There you go. Quite marked. Okay, here we've got our super powerful rare earth magnet here, really strong neodymium magnet, okay? Pretty much the strongest one I could buy, okay? And then here we've got a piece of aluminium, so another Lenz's law demonstration, okay? So you can see a real effect here. Feel that slowing down as you drop it. If you drop it on here, it makes a clanging noise, okay? But if you just drop it there, you can see that. All due to Lenz's law. Also show it for copper. It's not as effective with this piece of copper, but it is noticeable. And this one here, again, this lump of aluminium will make a clanging noise, but if you drop it here, it slows down just before it hits. Do it from a higher height, it's much louder, but yeah, the number one thing, this very thin sheet of aluminium, you can really see that's a noticeable effect. With a really strong neodymium magnet, you've got to be careful with these. Hi there, just temporarily rigged up an aluminium track here, a V-shaped track, just using 4 aluminium rulers. Now this is a non-magnetic sphere, and so if we let it go down the ramp, it flies down very fast, okay? Now we've got a similarly sized sphere here. This is from one of these Field Flux toys. This is a strong magnet. Now, 2 different things can happen here depending on where the poles are. So we'll see how I've got it here. So you can get this first, where you can see that it slows down periodically. So that's one type of motion, and if I change the poles around a bit, let's have an experiment. And get this right. Still there a bit. There you go. Like now it's just travelling at a terminal speed. Be useful to label the poles probably on this magnet so you could do it correctly each time, but this is just a rough go. Thank you to Albie Reid for pointing this out, and there's a journal article in Physics Education all about this, which I'll try and link to in the description. Hi there. Here we've got a pie case, and just suspended above it we've got 3 neodymium magnets. Really cool little demonstration you can do here, look. Not touching at all, okay? But spin this around, look, it spins that way. Spin it the other way. Spins the other way. Isn't that great? Not really touching it at all, okay? Lenz's law in action. Aluminium, strong magnet. Oh, and so from above, yet another lenses law demonstration.